So we will discuss image formation in the case of concave mirror. So there are various cases. We will discuss all the cases one by one. So first case is when the object is placed at infinity. Let's take an example. Suppose the sun, it can be treated as an object and we place a mirror on the earth's surface. Then in such a scenario, sun can be treated as an object which is placed at infinity. So when an object is placed at infinity or positioned at infinity, then the rays coming from that object may be considered to be parallel to the principal axis. So in this case, what happens is, this is a concave mirror, this is the pole, it's a part of a hollow sphere, the center of which is known as center of curvature, line joining P and C, that's principal axis. The midpoint of P and C is the principal focus. Now the object is at infinity. So the rays coming from the object must be parallel to the principal axis. These are the incident rays coming from infinity. After getting reflected from the mirror, these rays will tend to get converged at the focus. So this is where the image is formed. So image is formed on the same side as that of the object. So if you place a screen over here, then a point size image of the sun or that object placed at infinity will be obtained. So the image obtained is real. So nature of the image is, first, the image is real since it can be obtained on the screen. Second is, image is formed at the focus. Third is, image is point in size. It does not have any sort of dimensions, so it is point in size. So linear magnification would be 0, because linear magnification is the ratio of the size of the image to the size of the object. Here the size of the image is 0, accordingly linear magnification will be 0. So image is point in size. So in this case, image is found at the focus, but it is point in size. Right? Second case, what we'll do is, we will bring the object closer, much closer, but very far distance as compared to the dimensions of the mirror. So, second case is when the object is placed at a far away distance, not at infinity, but at a far away distance. In this case, the rays coming from that distant object will be parallel to each other. The rays coming from the object will be parallel to each other, but will not be parallel to the principal axis. So, this is the diagram. This is the pole. Again, it's a part of a hollow sphere, the center of which is known as center of curvature. I've told you numerous times, I've suggested you, whenever you draw a ray diagram, try to recall all the terms and definitions. So, line joining P and C, that's known as the principal axis. The midpoint between P and C, that is the principal focus. Now, object is at a very, very far away distance. So, look, these are the rays, these are the parallel rays coming from a far away object. They are parallel to each other, but they are not parallel to the principal axis. Right? In case object is at infinity, then the rays are parallel to each other as well as parallel to the principal axis. But in this case, they are parallel to each other, but not parallel to the principal axis. But the rays, after getting reflected, they will again get converged at the focus. Not at the principal focus, but at the position of the focus. So this is where the image is obtained. Suppose it is A dash, it is B dash. Try to understand the basic difference. Here the image is formed at focus. Here also the image is formed exactly at the focus. But the difference is, here the image is point in size, and here the image is of very, very small size. It is diminished, but it is not point in size. So the nature of the image obtained in this case would be, image is real and inverted. Second, image is formed at the focus. Image is formed at the focus. And third is, image is diminished. Diminished means the size of the image is smaller as compared to the size of the object. So linear magnification, mode of it is less than 1. Obviously, linear magnification would be negative because the image is inverted. So now what we'll do is, we'll try to bring the object much closer to the concave mirror, right? So case 3 is, now let's discuss case 3. Case 3 is when the object is placed beyond C. When the object is placed beyond C. So we're going to deal with case 3. Object placed beyond the center of curvature. Object placed beyond the center of curvature. Beyond C. Again, we need to draw the diagram. This is a concave mirror. It's a part of a hollow sphere, the center of which is known as the center of curvature. The center of the spherical mirror is known as the pole. Line joining P and C, that is known as the principal axis. This is it. This is the principal axis. The midpoint of P and C, that's principal focus. So as per the article, in this case we'll consider the object to be placed beyond C. This is the diagram. AB is the object which is placed erect in front of the concave mirror, right? In the first case, you consider this object to be located at infinity, then at a very far away distance, and then located beyond C. So the object is brought closer and closer and closer towards the concave mirror. So already we have discussed 4 rules for the image formation. Here, in order to form the ray diagram, in order to prepare the ray diagram, you can make use of any 2 rules. The first rule is incident ray from the object which is parallel to the principal axis after reflection in the case of a concave mirror will pass through the focus. This is rule 1. Ray parallel to the principal axis, after reflection it will pass through the focus. Second rule, incident ray from the object which passes through the focus, after reflection it will become parallel to the principal axis, like this. It will become parallel to the principal axis. This is it. So this is where the 2 reflected rays intersect. Here you need to drop a perpendicular, like this. This is the perpendicular. This is A, this is the object. Now it will become inverted. The image is inverted. So this is represented by A dash and this is B dash. So you can easily observe the image size is less than that of the object size. So image is diminished. Now here I have made use of 2 rules. You can make use of the other 2 rules as well. But in that scenario also you will get the same position of the image. I'll illustrate. Suppose the ray is incident at the pole. Then it will bounce back, obeying the laws of reflection. So that ray will again pass through the same point. Now if the ray is passing to the center of curvature, then after getting reflected from this mirror, it will retrace its path in the same direction. So what you will obtain is, you will obtain the image at the same position. Right? I will illustrate it with the help of the other diagram. Let's make use of the other 2 rules as well. This is pole, this is the principal axis, this is the center of curvature, this is the focus. This is where the object is placed. Right? This is where the object is placed. I am trying to redraw the same diagram, but I will be making use of the 2 different rules. This is the object. Parallel to the principal axis, it will pass through the focus. Right? If incident ray is incident at the pole, then it will bounce back into the same medium obeying the laws of reflection. That is, this angle would be equal to this angle. Again, you are getting the same position. This is the point of intersection. If the ray is passing through the focus, then after reflection it will become parallel to the principal axis, like this. It will become parallel to the principal axis. Third is, if we extend this, third is, if the ray is passing, incident ray is passing through the center of curvature, then it will retrace its path, then it will tend to retrace its path in the opposite direction. What I mean to say is that whichever rule you use, the position of the image would be same. This is where the image is obtained. This is A dash and this is B dash. So it is recommended to make use of only two rules. So any two rule can be used to get the position of the image, right? Now regarding its nature. First is, it's pretty clear. First is, image is real and inverted. It is real and inverted. Real image because it is obtained on the same side as that of the object. So if a screen is placed over here, this image can be obtained on that particular screen. And inverted because if this is the object, then this is the image obtained. Diminished in size, but it is inverted. So it is real and inverted. Second, what is the position of the image? It is formed between F and C. So in case the object is placed just beyond the center of curvature, then its image is formed between the focus and the center of curvature. Third is, as you can notice, image is diminished in size. That is, size of the image is smaller as compared to the size of the object. So linear magnification is less than 1. The mod of m is less than 1. But m will be negative. M is negative. Why m is negative? Because the image is inverted. For inverted image, m is negative. For erect image, small m is positive. So in this case, these are the properties associated with the nature of the image so obtained. Right? Now let's discuss case 4. The object is brought closer and closer, step by step. So now we will consider the object to be placed exactly at the center of curvature. So let's draw the diagram. This is the concave mirror. This is the pole. It's a part of a hollow sphere. The center of which is known as the center of curvature. The line joining P and C is the principal axis. And this is the focus. Right? Now we'll consider the object to be placed exactly at the center of curvature. It is placed at C. Object placed at C, which is the center of curvature. Now I have told you 4 rules. You can make use of any 2 rules which is applicable in this particular diagram, right? Any 2 rules. So first is incident ray which is parallel to the principal axis. After reflection, it will pass through the focus. After reflection, it will pass through the focus. This is the incident ray parallel to the principal axis. After reflection, it will pass through the focus. Second rule is incident ray passing through the focus. After reflection, it will become parallel to the principal axis. It will become parallel to the principal axis. So here it is the point of intersection of the reflected rays. So drop a perpendicular over here from the principal axis. This will give you the position of the image. So this is A dash and this is B dash. So this is the object. This is the object and its image is obtained at the same position and same size. Precisely the same size. So the size of the object is equal to the size of the image. You can make use of this rule as well. Ray incident at the pole. This will be the angle of incidence. It will bounce back into the same medium but will have the same point of concurrency. So whichever 2 rules you use, you will get the same position of the image. Right? So what about the nature? It is obviously real and inverted. Second, image is formed at C, exactly at the center of curvature. Right? Third, the size of the image is found to be exactly equal to the size of the object. So linear magnification is 1. Mod of m is 1. In case you make use of sign convention, so m would be equal to -1. Look, this is a very, very important point. 1 is suggestive of the fact that the size of the image is equal to the size of the object. And negative sign, as I told you earlier also, negative sign suggests that the image obtained is inverted. So for concave mirror, if the object is placed at C, then the linear magnification of the image is -1. M equals to +1. It is possible only in the case of plane mirror, where the image is virtual, erect and is of the same size. Right?